In this video, we're going to have a look at solution of triangles. Now, up until now, from the beginning of grade 10 onwards, whenever we've dealt with trigonometry, we've focused specifically on right angle triangles. And when we dealt with those right angle triangles, we used three main ratios. So we were always given a triangle like so, that had a right angle over there. We could label some angle theta in the triangle, and then we use the position of that angle to label the different sides of the triangle. The longest side, that's always going to be your hypotenuse. Then the side next to the angle, we call it the adjacent side, because this word adjacent simply means next to. And then if you went opposite to that angle, we call that the opposite side. And the three trig ratios that we had were sine of theta, cos of theta, and tan of theta, where sine of theta was the opposite over the hypotenuse, cos of theta is the adjacent over the hypotenuse, and tan of theta is the opposite over the adjacent. So these are the three trig ratios that we know well, and we've been using them since last year. But the question arises in grade 11 is, what are we going to do if we do not have a right angle triangle? Can we still work out the length of different sides or angles in that triangle if it isn't right angle? Well, the answer to that is yes, of course. And the three rules that we're going to learn to do that are the sine rule, the cosine rule, and the area rule. So let's go and have a look at those three rules individually, and as we go through them, we'll do an example of each that shows you exactly how you need to work with those three rules. But before we can do that, we need to catch up on how to properly label a triangle. So let's have a look at that first. So in any triangle that we're given, if it's labeled something like A, B, and C like so, all the angles would be labeled with a capital letter. So that angle there, that would be angle A, that would be angle B, and that would be angle C. So the convention that you can sort of understand that we use here is that angles are measured with a capital letter, and then when measuring the sides, we use a lowercase letter of the angle that is opposite that side. So if you go and have a look at the angle A over there, and you went opposite to it, you would label that side with a lowercase a. And then the same would be true for C. You would go for the side opposite the C, and you would label it with a lowercase c. And for the B, you would go across to the side opposite that, and you would label it with a lowercase b. So that's quite important for us going forward, because the formulas that we've got for the sine, cos, and area rule, they're all going to make use of this convention, whereby we use lowercase and capital letters of angles and their opposite side. And the method that you're going to use when applying each of these formulas is firstly to fill in as much information as possible. Then you need to determine what conditions are fulfilled in the given question. So if I give you a triangle, you need to look at it and say to yourself, what information am I given? And which one of the formulas does this information correspond to? And lastly then, you'll apply the rule in each given case. So now that we know how to label a triangle, as well as the methods that we're going to use, let's introduce the sine rule. So the first rule that we're going to look at is the sine rule. So if we're given the triangle ABC that's shown in the image there, then this side there would be little a, the side AC would be little b, and the side AB would be little c, because we're using the side opposite the angle, and then using a lowercase letter. Now the rule for the sine rule, and I'm just going to give you the formula. There will be another video that deals with how to prove these rules yourself. But the sine rule is given to us as one of two ways. Firstly, it can be given as A over sine of A is equal to B over sine of B, which is equal to C over sine of C. So just a couple of things to take from the formula quickly. Do you see that in every piece between the equal signs, we have the same letter? So we have an A on the top and an A in the denominator, a B in the numerator, a B in the denominator, a C in the numerator, a C in the denominator. So basically every single one of these expressions, if you want to link it all together, is made up of an angle and that angle's opposite side. So it's made up of an angle and the angle's opposite side. And because we've got equal sign in between each of those expressions, we know that for a fraction we can just swap them around. So we could actually write this expression as sine A over A, which is equal to sine B over B, which is equal to sine C over C. Again, the same letter in each of the expressions. And what's important to know as well from this is that the top version of the formula, so this version over here, that is used when we are trying to find the length of a side. Whereas the second variation of the formula, that is when we are trying to find an angle. So most importantly here, you need to make sure you know when to use each variation of the formula. And at the same time, you need to understand that you're only going to be dealing with two sides at a time. So even though all three of these expressions are equal to each other, you'll probably only be dealing with two at a time. And then if you wanted to prove the third one as well, you could. But that's a little bit more practical, and you'll see exactly how we do it when we go on to an example in a minute. And so that brings us on to the conditions that you need for the sine rule. So whenever you get to this section in an exam, you have to memorize these conditions, because by knowing the conditions, you'll be able to apply your knowledge a lot more easily. So the first condition is that you need two sides and an opposite angle. So you need two sides and one opposite angle, or you need two angles and one opposite side. So the same kind of condition on both times, but the difference being in one of them, you need two sides and an angle, and in the other one, you need two angles and a side. And make sure it is an opposite angle or an opposite side. So let's have a look then at the first example here. It says determine the size of angle O in triangle MNO and hence find the length of the side OM. Now, the difference between this question and the formula that we just dealt with is this triangle is labeled MNO instead of ABC. And so this is where it becomes important to try and remember the sine rule in words instead of trying to remember that formula off by heart. And the way that you can sort of remember it in words is the fact that it's always going to be side number 1 over opposite angle number 1 is going to equal side 2 over opposite angle 2. And then obviously you can swap the numerator and denominator around depending on whether you're trying to find an angle or a side. Just remember that whatever goes in the numerator is what you're looking for. So in other words, if you were looking to find the angle, then you would have written this out as opposite angle 1 over side 1 and so on and so forth. Okay, So by remembering it in words, it makes dealing with this triangle a lot easier. Because if we're trying to find the angle O, which is over there, you can clearly see we've got the opposite side from that angle, and we've got an angle and an opposite side over there. So let's just look quickly at what we've got in this question. We've got two sides and a given opposite angle. And so we then know that the conditions to use the sine rule are fulfilled. And so we can then use the sine rule. And the way that we're going to set it out is like this. We are looking for angle O, so that's what we start with. You always start with what you're looking for. So we would have sine of angle O over, and then we've got to go to the opposite side from angle O. And so the opposite side is given to us over here as mn. So you can write it symbolically, you can write it as mn is then equal to, we then use the opposite angle and side, or the other angle and side that we're given. So this is the opposite side, the 46 is that opposite angle, so it's going to be sine of 46 degrees over ON. You do not get marks for this step because in maths you don't get marks for writing out a formula. You get marks for substitution. So the substitution here would look like sine O over mn, which is 6, is equal to sine 46 over ON, which is 5. So therefore sine of angle O is going to be, when we move this 6 up, it's going to be 6 times sine of 46 over 5. And of course, we know that when we're trying to find an angle, we've got to make sure that we use the inverse function. So that means that angle O is going to be the inverse sine of this entire expression over here. So if you went to plug that in on your calculator, you would write shift sine, and then it gives us 6 times sine of 46 over 5, and you press the equals, and you get 59,68 degrees. 59,68 degrees. And then you can go and fill that in. So angle O is 59,68 degrees. Now, one thing that you might need to remember, especially when dealing with the sine rule, is that whenever you're solving for an angle, there is something called the ambiguous case. The ambiguous case. And that is because we know that when we're doing a sine general solution, one of the general solutions is that the angle is equal to 180 minus that inverse sine plus k times 360. And this 180 minus can show up in our triangle. So even though we worked out that O is 59.8, it would also be correct for us to say that O is equal to 180 minus 59.68. And if we check that on our calculator, we end up with 120,32. And if you go and look at that triangle that we've got over here, both the 120 and that 59 are plausible answers. Because if we checked angles of a triangle, whether this was 59 or 120, we would still be able to fit 3 angles into that triangle. And so often what will happen in this question is they will specify when you're working out an angle they will say something like O is acute or O is obtuse. Or alternatively, you will be able to see whether or not you have to use the acute or the obtuse angle. Because let's say, for example, that this angle over there was 70 degrees. Do you see then that 70 plus 120 gives us 190? And you can't have 190 degrees in a triangle. You can only ever have 180. So you just need to be aware of that whenever you're dealing with the sine rule and you're solving for an angle, you will firstly solve for the normal value, but then you will also go 180 minus that value. And if they specifically say O is acute, then you will use the value that's less than 90. If they say O is obtuse, then you will use the bigger value. Or alternatively, you may need to go and check your angles of a triangle to see whether or not you will be able to fit both angles in and still get 180 degrees from angles of a triangle. So that brings us on to the second part of the question then. And in this case, we're going to take that O is an acute angle. Okay, and that means that we will be using that 59,8 as our answer. And so if we wanted to then work out the length of side OM, we would need to have the opposite angle of OM in order to fulfill our conditions. And so when you're in a situation like this and you can clearly see that we want to find the length of this side OM, but we don't have all the conditions, well then go and force those conditions to appear, because we can use angles of a triangle to see that this angle N over there is going to be 180 minus 46 minus 59.68, which gives us a value of 74.32 degrees. So that angle there is 74.32 degrees. Now that we've got the opposite angle, we can use any combination of sides to figure out the length of OM. So as before, when writing out the formula, you always start by writing what you're looking for over its opposite angle, which in this case is going to be sine 74.32, and that is going to be equal to any opposite side and opposite angle. Now I'm going to choose to use the 46 and the 5 because it was given to us. And I'd rather use that than the 59, because if I had by any chance made a mistake in the previous question, by not using that answer, I'm not going to carry that mistake through. So that would give us 5 centimeters over sine of 46. Watch how I'm not writing out the formula because I don't need to. And that would be that OM is 5 times sine of 74.32 over sine of 46. And therefore OM is given to us as 5 sine 74.32 over sine of 46, and that is given to us as 6,69 centimeters. Don't forget to write your units. So in this example, we've not only looked at how to find the angle when dealing with the sine rule, but we've also looked at how to find a side, and we've discussed this ambiguous case which we're left with because of that general solution where we have that 180 minus present. And so just remember, whenever you're dealing with the sine rule, you firstly check that your conditions are fulfilled. You always start off by writing what you are looking for. And most importantly, if you are calculating an angle, you firstly find the angle itself using the basic inverse sine. Then you go 180 minus to get another value from the general solution, and you check which one you're allowed to use depending on what's given in the question as to whether they tell you the angle is obtuse, whether it's acute, or whether angles of a triangle won't work.